Hi, hello. Myself, I am Karthik Kupalpati, currently pursuing my Master of Science in Artificial Intelligence from National College of Ireland. Today, I am going to explain my research topic about my dissertation, integrating UMLS medical knowledge with DBARTA for symptom-based prediction. Um, the reason behind choosing this topic is there are mainly basically two reasons. The first thing is I was interested in doing the medical research, and second thing is among all those sectors in Ireland, uh, the sector that was lacking is little bit compared to the other sectors is health sector. So I was focused is on that sector. This research will help health sector to overcome some certain diseases. Yeah, the challenges in the research. According to a report published by WHO, every year 12 million adults are coming across with the heavier severity of diseases that can be predicted early in order to cure the diseases. The traditional symptom-based diseases is precisely rely on the uh, patterns of the disease and clinical trials, but that may take heavily more time than this research, and the gaps are in between. There is no systematic evaluation of dbata and umls integration for disease prediction, and the limited exploration of frozen strategies combining with text with the medical knowledge. Yeah, my research question is taken from the future work of the paper published by Hassan in the year 2024. The research question is how does integrating UMLS medical knowledge with DBARTA improves the disease prediction accuracy and interpretability compared to standard models? And what are the main research objectives that I have considered is creating a data processing pipeline of UMLS integration, and developing three UMLS integration variants, and conduct a comprehensive evaluation. And in this dataset, I'm going to give the overview of the dataset. Initially, the dataset was contained of 1 million rows. Exactly, it was 10 lakhs 25,602 rows, and disease classes was 49. After doing a stratified sampling strategy, from high frequency classes, we have taken less than 20k samples, and from the medium frequency, we have taken 10k to 20k rows, and from the low frequency it was taken 100% less than 10k rows, which results a total of 3,32,845. This was 32.5% of the original data set, and the data types that was used here was a binary, categorical, and multi-choice. It was clearly mentioned here, like what is the binary, like yes or no, symptoms yes or no, and categorical, it is single choice option, and multiple choice, it was mentioned here clearly, multiple selected. Yeah, in this slide, I'm going to explain how much data is used for training and how much data is used for testing and validation. For the training, I have used 2,32,991 rows. Overall, it consists of 70% of data. And for validation, I have considered 15% of data. And for testing, we have considered 15%, remaining 15% of data. The clear pipeline is mentioned here. What are the steps we have done in the each phase is clearly mentioned using a pipeline and a flowchart over here. In this slide, I'm going to explain UMLS future action. UMLS is nothing but Unified Medical Language System that was published by US National Library. It consists of 200 medical vocabularies in a single frame so that the medical analysis can be done easily. In this dataset, the UMLS is extraction for each data type is over mentioned here. Almost it taken very good results have been obtained over here, which results a good sign for our results. Here the phase is that UMLS, how much it is impacting the person's health, if it is severe, abundant, or bloody, acute, or chronic. Here overall from the dataset, it is mentioned clearly what is the patient's coverage if it is how much severe it is and how much abundant it is, and bloody, and what is the clinical significance is mentioned over here clearly. Yeah, here comes the main part, the methodology overview. The mainly it consists of three phases, and first thing is checking with the baseline models that are SVM, uh, dBERTA, and BioBERT, and SVM, BERT, and distill BERT, that I have done in the coding part. I will show you the coding part as well. And second phase is integrating with the UMLS integration development. Implement all the three fusion techniques: concatenation, gated, and cross-site attention. And phase 3 is comprehensive evaluation. That is one of the research question of our research, like statistical significance analysis and pre-disease performance analysis can have been done in the methodology part. Here comes the MedPred debugger architecture, uh, UMLS embedding layer design, CUI embeddings. Total there are 140 concepts and 250 dimensions by mean pooling, and semantic type embeddings, 38 types, 64 dimensions, and combined UMLS vectors. It is totally 384, and the in the table it's clearly mentioned how the processing is done and what are the outputs that we have came. Here comes the predict and debata architecture. How the initial what is the inside concept of the predict and debata architecture is shown here clearly. What is the predictions that I have doing and what is the models that have been used over here has been mentioned very clearly. What are the different types of models and what are the fusion layers that we have used, what are the multitask, and what are the predictions that are giving can be shown here. Yeah, in this slide, I'm going to show what are the different variants that I have used and what are the fusion type that I have used and what are the key features and what are the parameters that I have taken. Basically, we have considered three different, basically four: V1 and V1.5, V2, and ablation. And fusion types is concatenation and gated fusion, cross attention, and optimized, that is distill liberta. And what are the parameters? What are the different types of parameters we came across is for V1 we have used 97 million, and for V 1.5 it is 435 million, V2 it is 442 million, and Albation is 67 million. What are the results that we came across? Not of the results, disease classifications with the disease tasks is mentioned here. Here comes the evaluation framework. Here we can consider the two techniques, accuracy and precision. Overall correct classification across all four diseases, 49 diseases, and for the testing we have used 49,929 samples. The models that are tested are SVM plus TFDA, and this is a traditional model. And the coming to transformers model, but plus base, biobut and dbutta, and finally comes UMLS integrated, the models that I have mentioned, V1 and V1.5, V2. Here comes the result section. Here comes what are the different accuracies that we have obtained, here shown here, like what are the performances range only 0.08% points across all baseline models. SVM and SVM baseline matches exceeds transformation models, and biobet domain X show no measurable advantage over these models. High baseline creates limited room for the improvement. Here the results part of the UMLS integration part. Here comes like how much is the increase in the accuracy for each models that we have seen here. For the V1 it's showing 0.01 decline in the percentage of the baseline model, and for the V 1.5 it is showing 0.02 increase in the baseline model, and for V2 it was quite less than the baseline model. And for distill beer model it's showing 97.60 accuracy, which showing a significant result. uh, And statistical significance, the p-value is close to 0.487, not significant, and evaluation with baseline p-value it's 0.08 approaching the significance. And here the 95 at the 95% confidence interval, it's showing minus point 0.8 to 12%. Here comes the key research findings. The shallow and the integration problem. High performing baseline models do not reflectively utilize the additional knowledge features. And the second thing is model capacity interaction. And the third thing is fusion complexity. And the fourth finding is call flare prevention value are the key findings of the research that are clearly mentioned in the coding part and here as well. Here comes the answering the research question. The research question is answered accurately. UMLS integration providing marginal improvements, that is 13% max, significant when baseline model is greater than 97.5. Smaller model benefit more from the external knowledge than the larger models, and contribution achieved. UMLS extraction pipeline preserving 27 clinical clarifiers and semantic comparison of three fusion architectures identified shallow and three integrated problems phenomena is can be answered through this research question. Here comes the conclusion and future work. And UMLS key contributions are UMLS integration with the baseline models and the limitations. Only synthetic data lacks due to the large world language variability, and 12.8 symptoms without UMLS mappings. Future work test on the real data that is available from the various hospitals. Uh, Final takeaway is knowledge integration shows efficient and interpretability medical knowledge in resource constrained settings. Uh, Thank you for this giving me this